Okay, so here's example 2. So you'll notice this time you have the differential equation, because the equation is the derivative, the differential equation of 1 over x. So this time, your y does not affect your slope field at all. It doesn't affect the equation. It doesn't affect the original equation, because your slope is only affected by x. Okay, so these y values that we have up here are not going to change anything to do with the slope. The y values aren't going to do anything at all, really. Your x values, though, are going to be included in your slope. So for the point 3, negative 3, you'd plug in this x. So your derivative, your slope, is going to be 1 over 3, because that's your x value, so it's 1/3. Okay? Here where x is 2, it's going to be 1/2. Here where x is 1, it's going to be 1 over 1, which is 1. Okay? At 0, well, look what happens. You end up with 1 over 0. 1 over 0 is undefined. So this isn't going to exist. So we're going to say that it goes to infinity. Okay. You could also say that it's undefined. That's exactly the same thing. Because remember, if it's going to infinity, if you have an undefined slope, that means your function's going straight vertical. Okay. So that's not going to be anything that's going to happen. So you could say it goes to infinity. At negative 1, you're going to end up with negative 1. At negative 2, you're going to end up with negative 1/2. And at negative 3, you're going to end up with negative 1/3. Okay, so that's all of those. Now, keep in mind, if we move over to this point, my x value for this point didn't change. So this was the point 3, negative 3 had a slope of 1/3. So the point 3, negative 2, since the only thing in my derivative is the x, this is going to have the same exact thing as this, because all we're doing is plugging in the x. Okay, so it's going to have the same exact slope as this one. So where this chart, the y's stayed the same, this chart, my x's are going to stay the same, because the only thing that affects the slope in this situation is the x. So this one's going to be 1/3, this one's going to be 1/3, this one's going to be 1/3, all the way across. Okay, this one's going to be 1/2 all the way across, because it's x is 2 for all of these points. Okay, this one's going to be 1 all the way across. Okay, this one's going to be infinity all the way across. I know you're going to get tired of hearing me say that, but you're going to be glad that this one's all the way across, because some of them aren't going to be, right? Some of them are going to be different, where when they start getting affected by x and y, it gets a little bit crazy. So negative 1, this one's still going to be negative 1/2. All the way through. And remember, these are just the slopes. It's not anything crazy, just so we can make a slope field, so you can kind of see what your function is doing no matter what the c value is when you take the integral. Okay, so there's my chart of all of my slopes. And again, on the AP test, they're not going to give you a chart to fill in. You're just going to kind of have to go, okay, well, I know that this is a 3, so this slope is going to be this, and plug it in. Okay, okay, so here we go. So at the point 3, negative 3, so it's this point again, my slope is 1/3. So that means I'm going to go up 1 over 3. So it's kind of like this. Okay, and it's the same for all of my x values of 3. So it's the same for all of these points. So I'm going to just kind of sketch this in like this. I think that's the easiest way to do it. Down 1 over 3. So yeah, that looks like it's about the same line. So we're good. Okay. All of my x equals 2 points, so all of these values right here are all 1/2. So we're going to go up 1 over 2. So something like this. They're a little bit less steep. 1 over 2, so we'll aim over there. Aiming over there. And again, this could be a question on the free response or the multiple choice. Just kind of depends on how they want to ask you. Okay, at x equals 1, all of these have a slope of 1, so a little bit less steep again. Okay, at 0, they all go to infinity, so they're all undefined, right? This is undefined because we ended up with a 0 in the denominator. So they're all vertical lines. So that's essentially going to be like an asymptote, right? You're going to end up with an asymptote there, okay? All right, so let's do the next set. So these guys right here, -1. So all of these are going to be -1. So we're switching directions again. And again, this isn't hard. It's just kind of, it's one of those tedious things we have to do, right? But it's, at least it's nice that it's not something difficult. So these are all going to be -1/2. It's a nice change from all of those rules you have to memorize, right? Nice change from all the rules. So, okay, down 1/3, because all of these are -1/3. Okay, and you're done. So there's your slope field, okay? So this one looks like it's going to kind of curve in, right? So it's curving in and then has an asymptote. We're not sure what happens on the other side. So let's look at the point 1, 1. So 1, 1's right here. Okay, so 1, 1's right here.
Hello?
1, 1's right here. So we're going to go like this and then kind of curve it down like this, okay? So that's what my slope field is going to look like. Okay, so this would be my specific solution, the solution going through the point 1, 1 right there. Okay, what about the point -2, -1? So this one's A. So -2, -1 is this one, right? So that one's going to come in through here, maybe something like this, right? So regardless, they're both coming down. They're going towards the spot that I have the undefined slope, okay? And then they're going to have an asymptote. So they're going to look something like that. So you're literally just kind of guesstimating approximately what that's going to look like, okay? So everybody's could be slightly different, but you've got to make sure you follow that curve every time based on your slope field.